Hey everyone, welcome to STEM Time with Navya and Aishwarya. We are your hosts, Navya.
And Aishwarya.
The topic for today is the almighty algorithms. Before we get into this amazing topic, though, we will always start our episodes with a current event in computer science. On April 9th, 2020, the DOE/Lawrence Berkeley National Laboratory researchers were able to capture three-dimensional images of nanoparticles that were in liquid with atomic precision. They were also able to develop a super thin electrical switch that could revolutionize and miniaturize future electronic and computing devices with similar performance. I think this is absolutely amazing because this is another step towards even better and more efficient electronic devices, as well as smaller, which makes it more efficient. What do you think, Aishwarya?
I think it's actually amazing because just like how much and researchers are able to develop in order to advance where technology is going towards, it's just amazing to see the progress and the effort that people put into it. And just like what they're able to discover, it's an amazing thing itself. But I could talk so much more about it that we'd need a separate episode. But since
Yes,
today's
same.
about algorithms, I'm going to focus on that. So, to start with the basics, what are algorithms? So, algorithms are a set of instructions or rules to follow in order to do calculations or achieve some process. So, sometimes they can be complicated and sometimes they are very simple. But the main question is, how are they helpful? So, by using the correct algorithms, it makes a process faster. And efficient algorithms are necessary in order to choose from large data sets and analyze data across a broad spectrum.
So now the question is, what are the best types of algorithms? It is one that is accurate and efficient. But a problem is sometimes we have to compromise with algorithms, so choosing algorithms that are a little less accurate and perfect, because to be able to use a perfect algorithm, it takes a really long time, which doesn't necessarily make the algorithm efficient. So if an algorithm takes about 2 weeks to solve but is 100% accurate, it won't be as efficient as one that is 99% accurate but can take about a day.
Right, and for an algorithm to be both accurate and efficient, the algorithms consist of several parts. So the three main parts of an algorithm are sequencing, selection, and iteration. To start off, sequencing is a very important step for an algorithm to function properly and efficiently. So, to understand sequencing, think about this. Before you turn something in, you have to finish doing your homework. If you turn in your homework, for example, before completing it, the results will not be the desired outcome. So, in order to get the algorithm to function to our purpose, sequencing is necessary.
Another aspect of algorithms is selection. So algorithms are able to choose when to execute a set of steps. So this is usually done using if or if else statements. So this is known as a Boolean expression, which are statements that are either true or false. So if it is true, it will execute the set of steps. If it is not true, it will not execute the steps. For example, if you want a list of only even numbers, you would go through the numbers and say, if this number is odd, then add 1, which would make it even.
And just as important as sequencing and selection, the last main part of an algorithm is iteration. And to put it in the most simple words, it is basically repetition. You can repeat a set of steps for a certain number of times through a for or while loop. With a for loop, you can command for each word in a list, add 1. And by adding 1, this would count the number of terms in a list.
Another important aspect of algorithms is to check how accurate and efficient the algorithms are. So two ways of doing this is through empirical analysis and formal reasoning.
And in my perspective, Empirical analysis and formal reasoning don't work with one without another. So, to start off, empirical analysis finds the incorrect parts in an algorithm, and it helps in identifying inputs when the output is unexpected. Although it can find faults, it does not verify the accuracy of an algorithm, which is when formal reasoning comes into play.
So, in simple terms, empirical analysis is basically with the hundreds of inputs that you have, finding which inputs produces an incorrect output. So, basically, finding the faults within the algorithm. However, formal reasoning is the only method to prove total accuracy of an algorithm, and it is essential to programming because an algorithm is always correct and it is responsible for producing the expected outputs given a range of inputs. So a prominent form of reasoning is proof by induction. So this is also known as mathematical induction, in which mathematicians attempt to prove properties of a sequence of numbers because each step must be justified. So an analogy that I found through Khan Academy was a domino example that takes this formal reasoning and makes it much simpler for us to understand. So imagine we have million dominoes that are perfectly spaced out. But in order to prove that every domino will fall, we don't necessarily have to um, go through every single one and test whether it'll fall. What we could do is we can prove that the first domino will fall, and tipping over any given domino will tip the next domino over. So instead of checking it individually whether each domino will fall over, we can immediately prove just like that that a million dominoes will fall over.
So that's an amazing analogy, and I think that's one of the best ways to understand formal reasoning and how it ties in with empirical analysis. And while one finds fault, the other one is used to actually verify the accuracy. So before we end today's episode, I want to go over one last concept that I think is very important and very useful. And it's actually a technique that algorithms use. So, heuristic is a technique that algorithms use to find approximate answers and find good choices. It's a very efficient technique because it doesn't require an algorithm to discover every possible solution, and it does its best to find solutions that are accurate as well.
So that's it for today about almighty algorithms. I hope you guys had a fun time listening to this podcast, and don't forget to tune in to our upcoming podcast. Feel free to reach out through our Instagram page called STEM Time Podcast. Don't forget to keep learning new things. See you in the next episode. Goodbye.
Bye, guys!